Doppler effect is applicable for as we have learned already, right? Doppler effect is applicable for light waves because light waves are electromagnetic waves. Light is electromagnetic waves. Electromagnetic waves. So Doppler effect is applicable for light waves. Correct. Right. B, sound waves. Right, that also correct. Sound waves, some mechanical waves. Doppler effect is applicable for sound waves as well, right? C is space waves, right? There's no any waves like that, but they didn't mention anything specifically, so it is wrong. So the correct option is A and B, and it is the option number 1, right? Okay, question number 2. A source of sound is moving with the constant velocity 20 meters per second minus 1. Right. This is a source of sound. Is moving 20 meters per second minus 1, emitting a node of frequency 1000 hertz. Right. They didn't mention here, right, whether it is moving towards the observer or not. But let us assume the observer is here, right? But if you read that, the ratio of frequencies observed by the stationary observer while the source is approaching him and after it is crossing him. That means initially it is approaching the observer, right, with the velocity Vs. Vs is given like 20 meters per second minus 1, right? And the emitting frequency, that means the natural frequency of the source is also given 1000 hertz, right? And when the source is moving towards the observer, let us assume the apparent frequency heard by the observer is a stationary observer. We will assume that apparent frequency as FA1. Then what is the formula for FA1? Right, we need to mark the velocity of sound in air towards the stationary observer. Then we have to put a fraction here, right? In the numerator part, velocity of observer with respect to the wave, that means V, over velocity of source with respect to this wave, that means V minus Vs, right? Relative velocity, right? You need to change this arrow here, then V is in this direction, Vs is in this direction, so that will be subtracted like this, then into natural frequency like that. Then after a while, the observer is here, source is moving away with the same velocity, it is moving away. At this instant, let us assume the frequency heard by the observer is FA2. Then again we can find the apparent frequency heard by the observer, right? FA2. As you know, FA2 is V over V plus Vs into F, right? So the question is the ratio of the frequencies observed by the stationary observer while the source is approaching him and after it is crosses him. That means FA1 over FA2 is the question. If you divide these two, then FF cancel out, V is also cancel out, V plus Vs over V minus Vs. Now you can put the values, right? Speed of sound in air is also given, V 340 meters per second minus 1. Now this is 340 plus velocity of the sound source is 20 over 340 minus 20. Now if you solve this, right, that will be 360 over 320, then that will be 9 over 8. So the answer is 9:8. 9:8 is the answer. FA1 is to FA2 will be 9:8. So option is the third one, this one. பாருங்க மூன்றாவது கேள்வியா, sound source moves towards a stationary observer with the speed 1/4 of the speed of sound in air. The ratio of apparent frequency heard by the observer over the frequency emitted by the source. That means this is a source, this is an observer, right? the sound source moves towards the stationary observer. This is sound source, it's moving towards the observer, right, with the velocity 1/4 of the velocity of sound in air. Assume that the velocity of sound in air as v. Always we need to indicate the velocity of sound in air towards the observer, right? The observer is stationary. The natural frequency emitted by the source is f, and the apparent frequency heard by the observer is fa1. So we can write the formula, right, according to the tricks that I have explained during the class, right? This is relative velocity with respect to observer, that means v over relative velocity with respect to the source, v minus vs, into the natural frequency, v over v minus vs is v by 4 into f, right? Then this is actually v cancel out 1 over this, how you can solve this, 3/4 into f, that means 4 by 3 into f. Question is apparent frequency over the frequency emitted by the source, that means fa1 over f, then 4 by 3. 4 by 3 is the option, that is option number 4, right? So the question number 4 is a sound source S moves towards and away from a stationary observer O. This is a sound source, it's moving towards and away from the stationary observer, okay, right? And if the ratio of the velocities of the sound in air v naught and the velocity of the source vs is, that is v naught over vs is 11, right? The ratio of maximum and minimum apparent frequencies heard by the observer. This is a sound source, right? Let us assume the frequency emitted by the source is f, and it is moving towards and away. When it is moving towards the observer, when moving towards the observer, towards O, right? You know the apparent frequency is, right, velocity of sound in air is v over v minus vs. This time the observer will heard a maximum frequency, right? This is the maximum frequency into natural frequency. fa1 is the maximum frequency, f max, because it's moving towards the observer, right? So when moving, that means when the source is moving away, from O, then the frequency heard by the observer is v over v plus vs into natural frequency. That means this is the minimum frequency heard by the observer, right? And they are given that velocity of sound in air is v naught, so you have to mark this as v naught, right? Vs is okay. The question is the ratio of the maximum and minimum apparent frequencies, that means f max over f mini. F max over f mini equal to what? You have to divide this. If you divide, then that will be v naught plus vs over v naught minus vs, right? v naught vs is not given, but the ratio of v naught over vs is given. It's the value is 11, right? So how we can solve this? If you divide the numerator and denominator by vs, we can write this like v naught over vs plus 1 over v naught over vs minus 1. This is actually 11, no? So 11 plus 1, 12. 11 minus 1, 10. This is actually 6 by 5. So there's an option, fourth one is the correct option, okay? 5. A train traveling with the uniform velocity and sounding, that means it's whistling its horn. It's whistling its horn, right? A train is a source of sound, right? It's emitting a frequency f, sounding it's still passing a stationary observer. It's passing a stationary observer. Observer is here, right? It's passing the stationary observer. While it is passing, right, we can say when it is moving towards the observer, right, the apparent frequency heard by the observer is FA1. Right, we use the velocity of sound in air. We need to mark it towards the observer, right? Right. Now, observer is here. Source is moving away with the same frequency and same speed. Velocity of sound in air, right, we need to always indicate towards the observer. Now the observer is listening apparent frequency, say FA2. Question is, if the ratio of apparent frequency is heard by the observer is 6/5, right? The previous question is similar to previous one, right? That means FA1 over FA2 is 6/5. Then, what is the speed of train? You know the formula. FA1 over FA2, according to the first formula, right? We can say FA1 is V over V minus Vs into F. FA2 V over V plus Vs into F. From this we can have an equation like this. This is V plus Vs over V minus Vs into V minus Vs. That's it, right? So this is 6/5. Right. We need to find the speed of train, but the speed of sound in air is given 330 plus Vs over 330 minus Vs. Right. From this we have to find Vs. Right. So to solve this, there's a simple trick is there, right? 330 plus Vs. Right, 330 plus Vs over 330 minus Vs equal to 6/5. This is numerator part and the denominator part, right? If you add the numerator with the denominator, then what is the value? 660, right? If you add the numerator with the denominator, and if you put the answer on the numerator part, then that will be 660. If you subtract numerator from the denominator, then 330 is out. That will be 2 Vs. You need to do the same in the right hand side, right? You have to add 6 with 5, then that is 11. Then you have to subtract 6 with 5, then that is 1. Now you can simply solve this, right? 11 and this is actually 60. 60 Vs is equal to 60 divided by 2, that is 30 meter second minus 1. So 30 meter second minus is the speed of train.